So there are still coming people in, but with this I want to kick off the first Emconsoil webinar. Dear participants, I welcome you all to this first Emconsoil webinar. OVAM is of course taking a lot of initiatives within our Emconsoil network. We had the publication of a white paper. You normally receive our newsletters, and last but not least, we had already 4 ENSOR workshops that we organized in recent years. Recently, we took some steps in the expansion of Emconsoil, and firstly, it concerns the leadership within the PFAS team of the Common Forum. And next to that, we start here with the organization of webinars on the theme of emerging contaminants in soil and groundwater. Today in this webinar, we will start with 2 themes that appeal to many within the sector. At least this is apparent from the number of registrations we had for this webinar, namely more than 100. So let's start and have a look at the program. We have 2 important themes, namely the PFAS sampling, the challenges and recommendations that will be given a presentation by AECOM. And next to that, we will have IFlux, who will present a new method for monitoring the mobility of PFAS in groundwater plumes. So let me start with the introduction from Bram. Bram is working as an environmental consultant at AECOM Belgium. AECOM is an international engineering consulting firm and accredited soil remediation expert in Belgium. Bram is already working for more than 10 years in soil investigation and remediation, including on PFAS. His presentation will cover the main challenges and recommendations on PFAS sampling. So, Bram, the floor is yours, and I'll give you precisely 20 minutes for your presentation.
Thank you, Johan, for the introduction. I'll share my screen, and normally it's visible to all of you.
That's okay. Yep.
Yep. So we were invited to talk about PFAS sampling, mainly the challenges and recommendations sampling on these type of compounds. Our agenda will start with a very brief insight in AECOM and our expertise in PFAS, and why are these additional attention or these additional requirements needed for PFAS specifically. We go into some of the PFAS sampling guidelines, and these guidelines, they mainly focus on avoiding cross-contamination. An additional topic is the QA/QC, so the verification step that often is performed to verify if all the guidelines are followed. And we end with some of the key takeaways. First of all, AECOM and PFAS, we are an international engineering firm with a global community of nearly 9,000 environmental professionals. In Belgium, we have 2 offices, Leuven and Ghent. And within AECOM, we have more than 20 years of experience with PFAS. We also have our global technical practice group on PFAS, and it mainly started in the US and in Australia. As seen in this slide, it's a bit an outdated slide, because if you see to the European map, in the last few years, the investigation efforts and the focus on PFAS grew significantly. Also in our portfolio and projects in the Benelux increases as well. So then's the question, why all this additional attention to specific compounds of PFAS during sampling? I think all participants to this call know what PFAS are, so I won't pay a lot of attention to all the aspects, but yeah, we know they are challenging. These are the forever chemicals, and I would like to focus on two of their interesting but challenging characteristics, which impacts the way we investigate on these type of compounds. And the first one is that PFAS is in our environment. And since the 60s, it's used in various commercial items. They are manufactured using PFAS, and that means that a lot of those commercial items could still contain amounts of residual PFAS. PFAS mostly used for their fire, water, stain resistant properties. So that means that there is a potential exposure to PFAS through the entire life cycle, where it is manufactured, but also using potentially containing PFAS materials and the disposal of PFAS containing materials. Picture below shows that a lot of sectors, industrial sectors, you could encounter PFAS. The second challenge is that PFAS is evaluated in very low concentrations, low toxicological threshold values, and they push towards low laboratory detection limits. And those are then followed by low investigation threshold values and low remedial target values. These low concentrations are an order of magnitude lower, factor of 1,000, compared to the majority of conventional compounds of concern. So we are measuring these in micrograms per kilogram and nanogram a kilogram. And that's very important to know, of course. So the main challenge in PFAS sampling is indeed the downward raise of standards for PFAS and their analytical reporting limits. So we are measuring and evaluating PFAS in the PPT range and the presence of PFAS in various consumer products. And that leads to a significant potential for cross-contamination. Therefore, sampling integrity is paramount for generating reliable data that are usable for decision making. So they are challenges, but we can tackle them. We can tackle them by implementing specific PFAS guidelines when investigating on these different compounds. In the last few years, a lot of private companies or engineering bureaus like us have developed sampling guidelines, and also regulatory organizations like OVAM in Flanders launched these sampling guidelines. Within AECOM, as mentioned, we're investigating on PFAS more than 20 years. The experience grew over the years, and since 2016, we have an internal education and training program, and staff that are working on PFAS projects are internally certified to do that. So training and education is important. In addition, drafted international PFAS sampling guidelines to identify and avoid potential PFAS cross-contamination in the sampling environment. Little side note is that the principles from our internal sampling guidelines were also used for the development of the regulatory guidelines by Michigan Department of Environmental Quality, where AECOM was involved in. Training, education, and procedures are required to ensure that both project managers and also field engineers involved in these projects that include PFAS sampling of any media type use standardized procedures on PFAS project sites and collect high quality data. As mentioned, also OVAM launched these specific regulatory guidelines in 2020 together with VITO. Now it's included in CMA sampling directives. These sampling guidelines focus on specific points, and they all point towards avoiding cross-contamination. And in this presentation, we will tackle some of the aspects. And the first one is that sampling materials in the PFAS sampling environment should be PFAS free, and we should only use PFAS-free materials when we go out in the field and collect our samples. In the very first guidelines, there were very, very strict limitations because there was a lot of potential cross-contamination due to a lot of materials. And we see that in the last few years, these are generally updated based on new research or project evaluation. For example, it was in the beginning, we did not sample soil in any glass containers or glass jars. That is now allowed and generally used where this was avoided in the beginning. But still, there is a lot of uncertainty. And our message today also is to still remain vigilant for the unknown. Because we see that or have the impression that in the last few months, for example, sometimes the attention when OVAM initiated their guidelines, it was very strictly applied, but we see that it gets a bit loosened with some of the partners that we work with. So our message is definitely remain vigilant for the unknown and for specific PFAS related procedures. The topics below are an example of our internal procedures. We, in our sampling guidelines, there is an awareness identification system that differentiates the field sampling materials. And so we have clear items that we know that there is the potential risks, and we want to maximally avoid those in our sampling environments. There are also a lot of materials where there is some uncertainty, and there additional evaluation should be considered before you use that on your project site. And then others are safe based on data, based on research. It would bring us too far to speak on all kind of materials in this webinar, but for example, clothing and the PPE that you wear on site is questions that we often get. What can we wear? We know that a lot of items are a risk. For example, Gore-Tex, the water-resistant type of clothing. We do have project examples where concentrations of PFAS were discovered during a project, and it was unexpected. And after additional research, it pointed towards the use of improper clothing and the use of these kind of materials in the field. So there is a risk. But of course, we can't take our samples in our cotton pajamas. So often we also need to wear proper PPE, helmets, a raincoat, and so on. So there, try to be also pragmatic, but always be aware on site. If possible, test it. If that's not possible, document it, know that you use it on site, and avoid any contact between those kind of equipments or materials or clothing with the sample media. Not directly, but also not via rainwater, for example. To cover all these type of materials that you use, it's good to use sampling checklists. This is an example of the richtlijn PFAS-onderzoek launched by OVAM. We also have internal checklists, but it's good to have this available and used on site. Checklists are a good tool as part of a quality system to check and show that you have included the PFAS guidelines and in your pre-planning and in the execution of your work. And pre-planning is critical. Evaluate everything you are planning on using in the project area and the immediate sampling environment. That includes the sampling equipment, the personal protective equipment, also the decontamination water, and I'll in the next slide I'll cover that as well. Existing sampling equipment in wells, existing sampling infrastructure. An example for the sampling infrastructure is a project that we had in Australia, where samples were taken from an existing valve from a remediation infrastructure, and it seemed, or we observed elevated PFAS concentrations quite unexpectedly. Additional research showed that the valve was connected with a type of taping, and the new taping that compromised the results. So there were PFAS observed due to residual concentrations in the taping. So therefore, take into account all the equipment and all the materials that come in the immediate sampling environment. A PFAS-free water source. When we go on site and we take samples, we always use water from the site or from the client, or take water with us for our decontamination process. Be sure that you use PFAS-free water, because there are multiple examples where there are PFAS detects in public water or utility water. And if that is used to decontaminate during fieldwork, you can compromise your samples and you could compromise your results. So be sure and evaluate the water that you use. You can do that by taking additional samples for analysis. And then PFAS-free decontamination is, of course, also very important. Mostly all of you know the general cross-contamination principles, and of course they do apply on PFAS as well. But in PFAS we go one step further. Limit the reuse of materials between sampling locations, and to give an example, for example, taking groundwater samples, if you take the general guidelines into account and you use the disposables like PE tubing, silicone tubing, and so on, the risk for PFAS cross-contamination could be minimal. The only real thing to use in the different kind of monitoring wells is a water level probe or an interface probe. And all people that have been on site and have taken groundwater samples know that it's not always easy to properly decontaminate your water level probe, because normally you take your groundwater level, but also the end or the maximum depth of your monitoring well. So that means that you have to lower it meters and meters in your water and in your monitoring well. If that comes from an impacted well, you could cross-contaminate it to another well if you do not properly decontaminate. So there, for example, in PFAS project, to avoid that risk, we only use that water level probe to measure the top water level, and don't use it to measure the depth of the monitoring well when we are analyzing on PFAS. The whole decontamination procedure, there our advice is to go the extra mile. Do it very thoroughly, because the risks are there. Use PFAS-free decontamination products, because data showed that products like Deconex and Decon 90 do contain traces of PFAS. And we internally have a strict selection of products that we take on site to do our decontamination of our equipment. Use PFAS-free equipment for your decontamination process. For example, use intact PE buckets for your washing instead of old, possibly degraded coated buckets, because you don't know if they maybe are fabricated with the use of PFAS. And also include PFAS in the wastewater disposal. Then we come to the QA/QC. It's quality assurance, quality control. It's a tool to help and to verify if procedures are good and if they are followed. And a tool to do that QA/QC check is the use of blanks. Within AECOM, we tend to use these blanks to verify or prove that the results you provide are representative for the environmental media sampled, and that you have avoid issue of PFAS cross-contamination. We listed a number of type of blanks, and of course, depending on the goal, the complexity, and the size of your project, the amount of these blanks can vary. But you can have a selection of them, like the pre-investigation water blank. A typical thing that we include is that the water that you bring on site, like mentioned before, is free of PFAS. So you can take that a sample of that water and to check if it is PFAS free. Or if you bring new equipment or new materials on site and you are not sure if it's PFAS free or not, you also can take samples from that to see if it is possibly contaminated. You could also take equipment blanks during the decontamination process, and those are to assess the adequacy of decontamination process and or evaluate potential contamination from equipment. Generally, we decontaminate our hand augers, for example, between different drilling locations using a PFAS-free water source and using or decontamination equipment. It's good to implement a check after that process by, for example, rinsing your hand auger with the PFAS-free water or demi water, collect it, send it to the lab and check it. And if it's non-detects of PFAS, it can be a certainty that your decontamination was done correctly. You could also implement field blanks, a Duplo, for example, to assess cross-contamination from field conditions. And a trip blank can also be possible. It's a bottle that the lab can provide or that you take in the office with demi water to assess if cross-contamination was introduced during the shipping and the analysis. In Belgium, Flanders, yeah, we know that labs do have their own quality checks and are and have good and quality organization. I know, for example, in the States also the analytical aspects can be checked and can be cross-checked via additional blanks. That's a bit less applicable in the Benelux area. So covering these items, I want to end with some key takeaways. That is that there is a PFAS cross-contamination issue with some sampling related items when collecting samples for PFAS analysis. There is still lots of uncertainty as to whether other items are problems or not, and therefore stay vigilant and check what you want to use or what you have to use on site. Pre-planning to avoid PFAS contamination is key. Go the extra mile in the decontamination process and include QA/QC via blanks in each of these steps to verify if you are working in a good way, and you can show it also to your clients to say that you have done the maximum to have reliable and good data for good decision making. This was the end of the presentation. Thanks for the attention. If there are questions, they can be asked at the end of the webinar, I think, or you can take contact with us to see if we can cover it.
Okay, Bram, thank you for your interesting presentation. Also proving that, yes, new emerging contaminants also cause emerging challenges, because this was, of course, for other parameters not so important, but for PFAS, where we are really measuring in nanograms, picograms perhaps in the future, and also the fact that we are using them so often makes it very important to have these quality checks. I'll just launch a question for you, so you'll have to react immediately. You cannot wait until the end. There was one question in the chat. What is the range of PFAS concentrations that can be linked to cross-contamination? I think there was already a reaction from Vito, but I also like to present the question to you and hear your reaction.
Yeah, it can vary. It can vary a lot, actually. Yeah. If you have a cross-contamination between a source well to a delineating well, it can definitely have an impact on the results in that delineating well, so that the groundwater concentrations that you observe there are compromised, and maybe your contours of your delineation would have a complete different effect. So yeah, it's difficult to put concentrations on it, but yeah, it can vary a lot, and also because those limits are so low that yeah, already a minimum of influence or external influence on your sample, yeah, could have effect. So
So a little bit a similar question in that sense, that you mentioned some cases where there was clearly an influence. Do you know that there is an international study who has been looking and who's trying to quantify the impact of all those different factors you mentioned? Do you know that there is a study, or do we only have some cases where we know that there was an impact?
It's both sides. Indeed, there are studies available, and there is also the experience in multiple projects. I know in the last few years there also have been published new publications which tested a lot of generally used equipment where they also gave the green sticker. Let's say when we tested it significantly and we did not encounter any impact. For example, things like aluminum foil, the yellow post-its, things that also are included in the very first guidelines. And yeah, they would tend to avoid those items. Studies published in journals have checked that and have then stated that those items could be used in the environment. But as mentioned, yeah, there are a lot of materials, a lot of equipment, a lot of clothing types of materials, so it's difficult to tackle all, of course.
Okay,
I hope that's answered the question.
Okay, thank you, Bram, for your presentation, also for your reactions on the questions. And yeah, you were lucky. You were the first one to kick off this series of webinars we will organize from Emconsoil. And now we'll go to the second presentation, and I'll introduce to you the speaker. That's Marianne Joris. Marianne is working for IFlux since 2020 and has been a soil and groundwater consultant for over 20 years. Beside her expertise in soil and groundwater remediation, she built up experience in hydrogeological studies for infrastructure or infiltration projects. Her presentation will focus on the monitoring of PFAS in groundwater and how new technology is used to answer questions and manage the contamination in a proper way. So, Marianne, the floor is yours. You can open your presentation.
Thank you. Thank you also for the invitation and giving us the opportunity to share our experiences we built up the last years. So in the following 20 minutes, I'll explain how new methods for measuring groundwater and PFAS fluxes contribute to the management of PFAS in groundwater. With IFlux, our focus is on the monitoring of groundwater and its dynamics, a better understanding of the groundwater flow and the distribution and spreading of the contamination allows to act proactively and helps to prevent further spreading of the contamination and prevent the risks and damage related to it. Why do we focus on the dynamics of groundwater? Because we see that dynamics of groundwater and contamination are often underestimated. Too often, groundwater contamination is simplified to a static, homogeneous plume. And when we are doing conventional sampling, these are snapshots in time, as you can see here at the right. So we have just, which can result in peak concentrations high or low. When we are doing flux measurements, we perform measurements over a longer period, actually excluding these peak concentrations and including the dynamics. For PFAS contamination, where the concentrations are very low, but also the standards are very low in nanogram per liter scale, so the external influences can be very important and they will influence the results. So therefore, I think it's very important to look a little bit further than only the conventional low flow sampling and to see and to measure over a longer period to have more reliable and stable results. Maybe shortly, what is groundwater and mass flux? I think most of you will know, but just a very short explanation. Mass flux is the amount of contamination, PFAS in this case, is going through a certain area in a certain time. So we add the time component to the concentration. The mass flux is the concentration multiplied with the Darcy velocity. And the total amount of all those mass fluxes in an area perpendicular to the groundwater flow is the amount of contamination that is moving to a receptor downstream. The mass flux is a concept that's already known for a long time, but in the past, most of the time it's estimated based on concentration measurements, the hydrogeological circumstances, the permeability, the gradient of the groundwater, etc. Now there is technology, or there are devices that can really measure the mass fluxes and groundwater fluxes on site. And I will show you that in the next slide. So how do we measure fluxes on site? Hierefore we can use a passive sampler, the IFlux sampler, which is a commercial available product. The sampler is installed in a well, as you can see over here, and it's a modular system. We can combine different cartridges. We have a special cartridge for PFAS fluxes, but you can combine it with other contaminants for organic components or together with the groundwater fluxes. The IFlux sampler can also be installed at different depths. You can combine different depths in one well, and it's adjustable to the diameter of the well. Important, of course, is that you have a well in a good shape, that there are no obstructions, so the installation is possible. Because we adapt the diameter of the sampler to the diameter of the well, it's very important, because we want to prevent bypassing of the groundwater, bypassing of the sampler. Because we know that by installing a borehole or and a piezometer, a well on site, the soil is a little bit disturbed. We correct the measured results in the sampler for this distortion based on the available information of the diameter of the well, the diameter of the borehole, and the used filter material. So we can report quantitative results for the flux in the aquifer. So what I showed before were the devices to measure horizontal fluxes, which are the most important, I think, most of the time in the aquifers. But we also noticed that sometimes vertical fluxes can be very important as well. For example, the exchange between groundwater and surface water. And therefore, also vertical fluxes can be measured. And therefore, we use the sediment bed passive flux meter, which can be installed immediately in the sediment. Here you can see such a device. It has two open filter screens, which allows to flow in and out of the water, which allows to measure actually the vertical flow. And in between, there is a sorptive matrix. Actually, it's divided into 5 compartments, which allows us to measure in 2 directions, the up and downstream flow. Yeah, go to the next slide. Both type of cartridges can be filled with a resin that is specific for the absorption of PFAS. For the absorption of PFAS, we use a resin that is composed by Cyclopure, an American US-based company, and the resin exists out of cyclodextrin polymers. For our cartridge system, we have validated 11 components of PFAS, and the validation process is done by our partner SGS. So that means that we can report these 11, we can measure and report these 11 parameters quantitative. For the other parameters, because we know there are many more, we can also do the analysis and report them, but those results are semi-quantitative. What does that mean? That does mean that the validation process is not yet finalized. We are looking to it, but we are still working on it. And that are future plans. What are the mass fluxes are reported in the unit of micrograms a square meter a day, and the detection limits. We use a sorbent that goes to the lab, and for that the detection limit is 10 micrograms a kilogram, which is in more or less standard condition the same as 5 to 10 microgram a square meter a day, or comparable to 5 to 18 nanogram a liter of PFAS in groundwater. We also have a sensor for measuring groundwater flow velocity and direction. This is a digital sensor that measures continuously groundwater flow velocity and direction, as I already said. And these data are transmitted by IoT communication and to a platform and available in real time. The measurement actually is a temperature-based measurement, and the sensors are built in probes. We have a probe for measuring horizontal flux, where 2 sensors are built in perpendicular to each other. Based on the vector sum, the groundwater flow velocity and direction can be determined. Another probe is developed for measuring the vertical flow, and here 1 sensor is included, which can measure upwards and downwards flow of water. The vertical sensor can be installed immediately in soil, while the probe for measuring horizontal flow will always be needed to be installed in a well. For this one, for the digital sensors, it's not yet adjustable to the size of different available wells on site. Actually, we have a dedicated pre-pack filter which allow to easily install this digital sensor. For us, it's key to set up smart groundwater monitoring, and therefore it's very important that by start of a project, we will together with the customer determine or set out the objectives of the monitoring, because a monitoring plan will be completely different depending on the objectives. If you like to set up some global standards, if you like to follow up some dewatering systems, or if you like to monitor groundwater contamination and the spreading of the contamination. So based on the objective and the site-specific circumstances, we will always select the right sensors and measurements to perform on site. We can combine different kind of measurements with our, of course, our own sensors, but also other measurements as level sensors or quality measurements, etc. Meteo, weather stations, etc. that we can combine to better understand the water balance or the water system on site. And therefore, it will also be very important to choose out the right location to install the different sensor and to reach the objective of the monitoring network. Sorry, I doesn't, okay. Okay. So in the meantime, we performed over 100 of groundwater monitoring projects, not only on PFAS, we are not as big as AECOM. In the first place, we did set out monitoring projects with the passive samplers, but now we are also setting up real-time monitoring networks. With this digital sensor, we provide high-resolution data in time. We rely on the available technology. As you can see here on the right, you see an example of the horizontal flow sensor. We use our own sensors, but also other available sampling methods in the market. And we built up expertise which help to understand the questions and the needs and to collaborate with contamination experts. And we choose the most appropriate IoT communication, as you can see over here, based on the frequency of the measurement, data transmission, and connectivity. With the monitoring network, we provide a better understanding of the water balance and deliver clear answers to the questions that there are about the water system on site. So in the next slides, I like to explain with two simple cases how flux measurements are used to answer some basic questions, as, for example, are there preferential pathways where the contamination is spreading through? How much contamination is migrating? And is this being a risk for the downstream receptor? How fast is the contamination spreading? And are there other processes that impact the spreading of the contamination? And how can mitigation measurements or remediation measurements be improved or optimized to be the most efficient? Here we see the first case where flux measurements are used to design an active barrier and to follow up the efficiency of an active barrier. That's what we often see until now. Actually, I have to say that most remediation is preventing further spreading of the contamination. Or in situ remediation is focused on preventing the spreading because the source contamination or they are not yet very well developed, or there is a lot of uncertainty. So preventing of further spreading and the risk is needed. So with the flux measurements are used to characterize the high flux zone and to estimate the amount of product that has to be injected or the measurements to be taken to prevent the further spreading. A first case, here as you can see in the UK, actually they wanted to, it is an airport, a local airport, and downstream there was a nature reserve. There was a contamination with PFAS detected, rather high concentrations. Although the contamination was not yet completely limited, they already wanted to install a barrier downstream to prevent the spreading to the nature reserve. I think in this case, it was worth thinking about it, just also because the vertical limitation was already clear, because it was an underlying clay formation over there, which was, so the vertical spreading was very well known on site. And the horizontal spreading, it was more or less limited at that time, but not completely, but okay, it was good enough to take the first action in the area of the airport location. So it was a heterogeneous soil. On top there was some made ground, underlying alluvium and river terrace deposits. The wells on site were heavily contaminated, and it were large wells used over there. So we installed 3 different samplers in the 3 different formations to evaluate the flux or the mobility of the contamination. And as you can see below, flux measure, you can see the figure with the flux measurements. And as you can see, the mass flux in the underlying layers in the river terrace deposits were much higher in the upper layers. So there was a very important knowledge to design the pilot in first case, and the pilot of the barrier installation. A second case, there was a fire brigade training ground, a very heterogeneous soil, and also over here as well, a barrier had to be installed to prevent further spreading of the contamination. The layers, the soil layers were very heterogeneous, going from sandy to gravelly material, calcareous clay with occasionally shells, and vertically limited by a mudstone layer. In this case, the contamination was already delineated, and also in depth, there was a vertical delineation. Here underneath, below, you can see the concentrations. There was a well with a shallow filter and a well with a deep filter, and it was completely, it was contaminated. Because of the heterogeneous aquifer, it was very difficult to, it was very uncertain to just estimate the fluxes based on those concentration measurements and the limited hydrogeological data available on site. And therefore, flux measurements were performed in the available well on site. You can see a picture where we install a flux sampler in the well, and this one is the preparatorily plan for installation of flux sampler. On this side, there were, in the available wells, there were flux measurements performed at 6 different depths. There was already information available about the conductivity. Each PT drilling was performed, so zones of high and low permeability were known. So most samplers were installed at the high permeable zones of high hydraulic conductivity, but also at low conductivity zones, 2 flux samplers are installed. As you can see, the fluxes vary in depth, and as expected, high fluxes are measured at zones with high hydraulic conductivity. But it's not always related to the conductivity. Also, the fluxes can also depend on the contamination and the amount of contamination and the characteristics of the contamination. So these flux measurements allowed to better estimate the total mass discharge moving downstream and better design the barrier, so that from start the right amount of product was injected in place to prevent. Actually, the measured fluxes were higher than the fluxes estimated based on the available results of concentration hydrogeological conditions. So by performing flux measurement, was calculated that more injection product was needed and had to be injected, and they could save time and money because they didn't have to go back to the site to do a second round of injections. These results will also help the remediation contractor to commit to their objective of the barrier and to commit the results. After the installation of the barrier, the efficiency of the barrier will be followed up with flux measurements downstream of the barrier. Then maybe we look a little bit in future. Last month we just have a kickoff meeting for the live project Capture, which is coordinated by EBO, and we work together with SGS and Greensoil, also the Italian drinking water company Viaqua, two Italian universities, the Politecnico Institute of Milan and Bicocca, also University of Milan, and the Swedish University of Lund. We will, together with SGS, we will evaluate the best way to combine target analysis with or groups analysis as for fluorines, as AOF or EOF analysis, and top assays. During this project, we will also evaluate different remediation technologies or treatment technologies for PFAS contamination, and the ecotox effect and risk evaluation and the ecotox risks of PFAS individual, but also a combination of those compounds. And we will set up a pilot testing together with all the partners to test all these evaluations, to test all these different aspects on site. During this project, we will have the opportunity to build out our expertise with sampling of PFAS, and we will set out monitoring networks for the different pilots. With IFlux, we are in the lead of work package 6, which is the monitoring of the different work packages and the monitoring on site, which is as a glue of the different work packages. So, okay, I thank you for your attention. And if you have questions, please shoot.
Okay, thank you, Marianne, for this very instructive presentation. In the chat, I have for the moment one question, but I expect there will be others who will join. And that question is there any correlation between the hydraulic conductivity and PFAS concentration?
You mean, I think it's of course, there is a relation, I think. It's the same as for other parameters. Take a look if I understand the question right.
Otherwise, perhaps the person who asked the question can clarify what it precisely means. Hendrik Plus.
Yes. Because like in the previous project that I did, I didn't really see like clear correlations between if there is a very high hydraulic conductivity, there is not necessarily a high PFAS concentration.
No, because indeed, actually, if you're measuring concentration, you do not take into account the hydraulic conductivity. That's the additional we do with the PFAS flux measure, we do with the massa flux measurements, is that you will include these hydrogeological characteristics in combination with the concentration measurement. Like a concentration measurement is just it's a determination of the amount of mass available. It's a concentration measurement, but it doesn't take into account the hydraulic conductivity, for example.
Okay.
But the mass flux, if you measure the mass flux, it will take into account this hydraulic conductivity.
Okay, thank you. Are there other questions? I invite other persons if they have still questions. It's your possibility to ask an expert. It has been very clear, your presentation, Marianne. That's my conclusion. Thanks for this presentation. Also, thanks for reacting on the question. And I'll finish this first webinar by thanking some people from the organization who were behind the screens and that you didn't see today. But these ones are Wim van den Driessen from the Association of the Remediation Experts in Flanders, who did a lot of preparing work. Nele Bal, who was organizing this from the OVAM, and also Stefan van Geenhoven, who was responsible for the more technical points of this webinar. So this was successful on the technical side, but also I think of what we have heard from the content today. What rests to me is to invite you to the next webinar. Perhaps you have seen in the program that from now on every Thursday for the next 3 weeks, then we will organize webinars. And the next webinar will be on the 17th of November, the same time and time slots, and it will be about PFAS analysis in soil, water, air, blood, and food. And that will be given by Eurofins and SGS. So we're nice in time. So I also want to thank the speakers for keeping the time into what they have presented. And so it only rests to me to say to you, have a nice day and see you next week.